Good morning, dear students. Welcome back to physics class. For today's class, I would like to teach you one experimental work. It is to establish relationship between weight of a rectangular wooden block and the maximum force required to just move on a horizontal table. What is aim for this experiment? It is to establish relationship between weight of a rectangular wooden block lying on a horizontal table and the maximum force required to just move it using a spring balance. Apparatus required are rectangular wooden block with a hook on one side, a spring balance. It is in the range of 0 to 1000 gram, or it can use to measure the weight up to 1000 gram. A weight box, a fine thread and 5 pieces of mass, each of 100 gram. Theory is whenever an object is made to slide over another surface by applying force, force of friction opposes its motion. It acts in opposite direction to the applied force or the motion of the body. As the force applied on the object increases, force of friction also increases and compensates it. Net force on the body remains 0 and therefore body does not move. When the force is further increased, the frictional force also will increase up to a certain limit. Beyond this limit, body just begins to move as unbalanced force acts on it. This maximum value of force of friction before the body just starts to slide over another is called limiting friction. Let's see the procedure. Clean the tabletop. Take a spring balance. Note its least count and 0 error. Measure weight of a rectangular wooden block with help of the spring balance and record it. Take about 1 meter long thread. Tie one end of the thread to the hook of the wooden block and other end to the spring balance. Place the wooden block on the table with horizontal surface in such a way that the spring balance could be held at another end of the horizontal plane surface. Apply a small force on the wooden block by pulling the spring balance as shown in given figure. Gradually increase the force till the block just begins to slide on the horizontal table. Note the reading of the spring balance. It measures the force applied to mass of the wooden block. Now keep on adding the weight each of 100 gram on the wooden block and notice the spring balance reading. Record all the observations in a tabular column. Let us see the observations. Least count of the spring balance and its error and weight of the wooden block are recorded. They are in unit of gram weight. Record all other observations in a tabular column given below. In its first column, mention the serial number. In second column, mention weight placed on the wooden block. Let it be W. In third column, mention total weight being pulled. It is the sum of weight of the wooden block and weight placed on the wooden block. Let it be N. In fourth column, mention total force pulling the block. It is reading of the spring balance. It is numerically equal to the frictional force. Let it be FF. And in fifth column, mention the ratio of FF to N. You have to notice that weight placed on the wooden block, total weight being pulled or normal reaction, and the total force pulling the block or reading of the spring balance or the frictional force all are expressed in the same unit. It is gram weight. Calculation part is reading given by the spring balance shows the maximum value of force of friction acting between two solid surfaces just before the object sets into motion. Find the ratio of total force applied to pull the block Ff to the total weight being pulled in. Plot a graph between total weight being pulled, that is normal reaction along x-axis, and spring balance reading, that is limiting friction along y-axis. The graph becomes a straight line as shown in given figure. The result is, it is observed that as the total weight of the wooden rectangular block increases, the maximum value of force of friction also increases in the same ratio. The result also shows that ratio of Ff to N is a constant, that is Ff is directly proportional to N. It is the required relationship. What are the precautions? First one is the string should be inextensible. Second one is the portion of the string between the block and the spring balance should be horizontal when force is applied on the block. Third one is surfaces of the table and the block in contact must be smooth. Fourth one is the mass of the rectangular wooden block should be not be so large that a large force is required to make the wooden block slide. Fifth one is reading of the spring balance should be noted only when the wooden block just begins to start to move. And sixth one is before use, adjust the zero of the spring balance. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.